Okay, so today we're going to talk about real numbers and their subsets, and we're very excited about that. That's why the exclamation marks are there. So you can see in your packet that you're given the definition of the different subsets we're going to talk about today. If you didn't know them already, I'm sure at some point you've seen all of the different ones we're talking about. The natural numbers, the whole numbers, the integers, rational numbers, and irrational numbers are the subsets we're going to be covering today. And so first let's look at the natural numbers. So we can see on our packet that the definition or way that we're going to think about the natural numbers are the counting numbers. So given this set of numbers, these are all real numbers, I want you to write down on your packet the natural numbers that are within this set. So I'm going to ask you to pause the video in a second. You're going to pause it, you're going to write down the natural numbers, and then you are going to unpause it when you are ready and check your work. So at this time now, go ahead and pause the video and write down the natural numbers. Alright, so hopefully you wrote down the numbers 1, 3, 12, and 1,503,456. Those are the natural numbers within this set here. And again, just to emphasize what are the natural numbers, we can say they are the counting numbers. Moving on, let's do the whole numbers. So again, we're going to follow the same routine that we just did. So I want you to write down what are all of the whole numbers. I'm going to drag them into the space. You're going to write them on your packet. So pause the video, write those down, unpause when you're ready to verify that you have the correct whole numbers. So go ahead and pause the video. Okay, so it's the same thing as the natural numbers from before, except for now we have also included 0 in there. So we should have 0, 1, 12, 3, 1,503,456, because we can see in our packet it tells us that the whole numbers are the natural numbers and 0. So notice that the natural numbers are a subset of the whole numbers. Moving on to the integers. So we can see from our packet that the integers are going to be whole numbers and negative natural numbers. So all of our whole numbers and the negative numbers now. So again, pause the video, write down all of the integers, unpause when you're ready to check your work. Alright, so our integers should come out to be -7, 0, 1, -1, 3, 12, and 1,503,456. So notice that the whole numbers and the natural numbers are both subsets of the integers. Moving on to the rational numbers. So we can see from our definition of rational numbers that rational numbers are integers and numbers that can be written as the ratio of two integers. So what do we mean by the word ratio? Ratio, remember, usually means fraction, but also keep in mind that integers can be written as fractions, so that's why they are still considered rational numbers. For example, I can write the number -7 as -7 over 1. So that is the ratio of two integers. So I want you to pause the video, write down all of the rational numbers, unpause when you are ready to check your work. Okay, so all of our rational numbers should be -7, -7/3, 0, 3, 5/4, 12, 3.14, 1,503,456, 1/2.00000001, -1, 1, 4/17, and -17/4. All of those meet our definition of values that can be written as the ratio of two integers. And if you're a little bit confused about perhaps L here, this decimal, and H, the 3.14, those could be written as, this could be 314 over 100, and this could be 1 over 10 million. So both of those can be written as the ratio of two integers. Also, if you look at C here, -7/3, notice that if you were to type that into your calculator, that would actually come out to be a repeating infinite decimal. So repeating infinite decimals can be written as fractions. Think about like 1/3. 1/3 is 0.3 repeating, or 2/3, which is 0.6 repeating. 7/3 follows that same idea, and so that is still a rational number. Alright, and then our last category before we talk about real numbers is the irrational numbers. So if you're a real number, but you're not a rational number, then you're an irrational number. So irrational numbers are numbers that cannot be written as the ratio of two integers. So by process of elimination, you should be able to figure out which ones are the irrational numbers here, but just for fun, I'm going to let you pause the video, write down the irrational numbers, and then unpause when you're ready to check your work. Okay, so we should end up with the square root of 5 and pi are the two irrational numbers within this set of real numbers. Neither of these can be written as the ratio of two integers because the square root of 5, although it could be written as the square root of 5 divided by 1, 1 is an integer, but the square root of 5 is not an integer, so that would not be the ratio of two integers. The same would hold true for pi. Notice also if you were to type these values into your calculator, they would be non-repeating infinite decimals. And anytime you have a non-repeating infinite decimal, that will be an irrational number. So then let's talk about the real numbers. So then that means all of these values here that we've looked at are actually going to be real numbers. So if we highlight all of them and we drag all of them over here into our space, then that is all of the real numbers. So if we think about this, we could make a little picture to show the subset of numbers. So we can start with the natural. So if I put this in a box, and then I have the whole numbers. So the whole numbers include the natural numbers, but now have added 0. And then I have the integers. So the integers include the natural numbers, the whole numbers, and now also the negative numbers. And then after the integers, I have the rational numbers. And the rational numbers include all of the natural numbers, all of the whole numbers, and all of the integers. And then outside of that, I have the irrational numbers. These are in a category by themselves. They are not including any of the rational integers, whole, or natural numbers. And then all together, these are the real numbers. Wasn't that fun? So now one thing to point out real quick before we end the video is that these words are going to be very important vocabulary throughout this year. There are words that you've heard before, but specifically rational, integer, and irrational are going to be things that are going to come up not just in numbers, but when we're talking about functions and expressions as well. And so it's very important that we understand when we hear the word rational that we're talking about a ratio, and when we hear irrational, it's something that cannot be written as a ratio, and that we know what integers are as well.